Welcome back, everyone. Hope you had a nice lunch. I see we're losing people little by little. Some people had to take the train home. But it's too bad because I think this session is going to be one of the more interesting sessions for us. Maybe I'll just give you a little bit of background before we get started. At COAR, we really think it's our role to try to not only monitor external trends for repositories, but also in some ways chart the future for repositories. And in 2016, I think we launched what we call the Next Generation Repository Project, where we had a very large group of international people who were discussing what would be the future functionalities and behaviors for repositories. And one of the major use cases that came out of that work was that repositories should play a more fundamental role in the publishing process. Rather than collecting already published articles to make them publicly available, they should be an active part of the publishing process. And based on that use case, we started to model some of the technologies that would be helpful to be able to advance this idea. And a small group of us got together in Paris, I believe, and we came up with some specific technology that would be very useful to support this use case. And several months later, we were funded by the Arcadia Foundation in the UK with quite a large fund to try to advance this use case. And the technology is now called the COAR Notify technology. And we're about 2.5 years along in the funded project where we're working on implementing COAR Notify in the repositories and other types of peer review services. I won't talk much more about it because our presenters will. But I'm very pleased to introduce Eloy Rodrigues and Paul Walk, who are both principal investigators on the COAR Notify team, along with myself and Martin Klein. But it will be Eloy and Paul presenting today. And we're happy to give you an update on pretty significant progress, I would say, around COAR Notify and the ecosystem that it can facilitate. So, with no further ado, I would like to introduce Eloy Rodrigues to begin the presentation.
Thank you, Kathleen. And good afternoon, all. I hope that I will be able to keep you awake after this lunch break, and speak slowly. I don't want the translators to become my enemies because I tend to speak very quickly. So this session is about COAR Notify and how it contributes to facilitate the creation of ecosystem of publish, review, curate systems. But I will start to make an introduction about the context about the publish, review, curate system, and then Paul Walk will walk you through the details of the protocol and how it has been already applied in some contexts. So we until now we have been living in a world where the dominant model, and is still the dominant model, is that peer review occurs before publishing. So if I want to publish an article, I submit it to a journal, and the journal does some kind of evaluation if it fits to the journal topic, and then if yes, then they probably send it to peer review, in most cases to blind peer review, and then if after eventually several interactions, the paper ends up being published. But what happens in the current model is that many times there is not just one cycle of submission and review. So, for instance, I may think that I can publish in Nature or Science and submit an article there, and then it can be desk rejected, or it can not be desk rejected, but then sent to peer review, and then the conclusion of the peer review is that it should not be published there, and with the recommendation to submit to a second journal. And then I submit to a second journal, and there is another round of reviews that are, again, not known except for the reviewers themselves and the author, and this can occur several times. And it has two main consequences, obvious consequences. One is that there are long lag times between submission and publications, usually many months, in some cases a year or more than 1 year before the article is, between the moment where the author thinks that result is ready to be known and to be published, and the moment that it is really published. And the second thing, because of blind peer review, is that there is really a loss of energy, because several people are doing the same work again. Not knowing that others are already done that. So, and in a system where we are publishing more and more, and where it is difficult to find reviewers, this is really a waste of time. So, as you certainly all know, in scholarly communication and in journal publishing, there are mostly four main functions of journals, and they are registration. So I accomplish this result. I have this work that I want to be credited and recognized by, and I publish it. I make it public. The second function is certification. So it's not enough that I say that I made this, that I come to this result. It needs to be certified by peers, by people with the level of knowledge adequate to certify that. And then there is a function of dissemination, so that that result reaches and can be accessible to anyone that is potentially interested in. And then the fourth function is archiving, so preserving that result for future use. In the printed world, these four functions needed to be performed by the same entity, the journal. And journal did this very well. But on the digital world, we can unbundle these functions, and so repositories can perform the first and the last function, so the registration function and the archiving function, and the certification and dissemination functions can be performed by other services. So these four functions do not need to be bundled as it occurs in the printed world. And this vision that is now becoming probably more widely recognized and understand and accepted was not really a new vision, because the creator of the first repository, Paul Ginsparg, already in 1994, in a different formulation, was already suggesting that we could and the repositories could do this. So we are, in a way, I usually joke when I make this kind of presentation. I say that we are like on the movie, we are back to the future. So we are just doing something that was already anticipated many years ago. And recently, especially with the pandemic, there was really an acceleration of the adoption of preprints and innovative models and services for publishing. So the rise of preprints, especially on biomedical sciences, was very significant. But we have seen in the recent years, in some cases, this started to happen before the pandemic, but really got traction during the pandemic and after the pandemic. Several new services and models to become more widely used. And in fact, this is a slide from Jessica Polka, who already with 2 or 3 years ago. We will need to have more logos here. There is really an ecosystem around pre-printing, publishing, and feedback. Some of these services, some of them are more close to traditional journals like overlay journals, and we have here, for instance, in the room, people from EpiScience, that is an overlay journal, to others that are much more kind of informal or less structured, let's say, type of feedback services. And this approach is also starting to get traction and support from funders. So the position paper from Coalition S towards responsible publishing, that I think will inform the new strategy of Coalition S that is not known yet. I think it will be known in the coming month or so, really supported this vision of new models of scholarly publishing, where authors decide when and where to make their work available, and then the certification and the review, the peer review, occurs on a more transparent way, and it may end up on being published or curated by a journal. And also related with this Coalition S paper, there was a consultation to I think it was 11,000 researchers around the world about this vision of Coalition S, and there was broad support to this vision, especially related with posting of preprints and open peer review. There was a vast majority of the respondents that also said that they would support this vision. And a couple of years ago, in 2024, the Bill and Melinda Gates, the new open access policy announced by the Bill and Melinda Gates Foundation, is also based, is not requiring anymore the version of record, is not supporting anymore the payment of APCs. So APCs will not be supported by the grants of the Bill and Melinda Gates Foundation, and is just requiring the publication of preprints. So we are really on a moment where this model of publish, review, curate is getting traction and is getting momentum. So what is the publish, review, curate model? As it's it's probably obvious from the name, is a model that breaks the process, the publishing process, into the different parts or stages. So the first one, the publish one, is where a research artifact, and again, the research artifact may be different things. So it can be an article, a data set, a study registration, software. It can be different types of research artifacts or contributions, is made public, and it's made public in a repository, in a preprint server, in an institutional repository, in a disciplinary repository, in a catch-all repository like Zenodo, and that's the first stage of it. So it's the publish part. Then, in the review stage, reviewers evaluate that research artifact, so the certification function that I show you on that slide, and provide feedback. So they provide feedback, and that feedback can eventually result in a revision of the original contribution or the original artifact, and in fact there might be several rounds of it. And then in the final stage, those research artifacts, jointly with the evaluations, with the reviews, can be compiled into collections, and they might be summary judgments about them. So, and decisions, binary decisions like publish, not publish, endorse, not endorse. That's not all the services as this have this kind of final results, because in some cases you just find the artifacts, the original research article, for instance, and then the reviews. But in many cases you will find the research artifact, the reviews, and then some kind of final evaluation or judgment, like endorsement or a publication in a journal, for instance, in an overlay journal. And in recent years, we have seen a growth on the adoption of this model. So this is a graph that was published last year. So the data, even the data regarding to 2024 is incomplete, because this was published in October. So I think the data is until July or August. But you have you can see that there is an increase on the last years on the number of publications that were submitted to these published review Curate platforms. So in short, and to conclude, and then pass back to Paul, there is significant benefits of this new model. One is, of course, the rapid dissemination of research, because, again, when I as an author, think that I have a result that is ready to be shared, to be published, it will become immediately public. I don't have to wait 6 months or 1 year to be accepted to be published in a journal. The second one is pretty flexible and interoperable, and maybe also Paul will come back to this. But as you can see already, on the ecosystem there are very different approaches, many different services, both review services and repositories. It is decentralized by design, and this is also a very important point that I'm sure Paul will come back to. And another advantage that I want to stress now, it is because it can lower the costs, and especially can distribute the costs between, for instance, institutional repositories that are living and are sustained by institutions, and they will have that cost anyway. So, for instance, journals or other types of services don't have to bear the costs of archiving, because those costs can be distributed between the service and the repositories that host the resources, and can scale to different preprint servers, to repositories, to review services of different types. And with this, I hand over to Paul. As you will see, it really requires, using the Notify protocol, it really requires a modest technical investment. So, Paul, I hand it over to you.
Good afternoon. Hope you're still awake. I'm going to get a little bit more technical now, I'm afraid, so bear with me. So I'm going to be describing the Notify protocol and how it applies to the particularly the review part of PRC. Just a quick note to say that as Kathleen alluded to at the beginning, a lot of this work, the majority of this work, has been funded by the Arcadia Foundation, so we're very grateful to them for that. So the context behind Notify is that our starting point is we have this globally distributed network of repositories. And that this is naturally resistant to any kind of monopolistic control. So this is a good thing that we have, and this is well established already. And we have the web, and the web is very mature. The technologies that underpin the web are very mature. They're mainstream technologies. In the past, certainly in my career and even earlier than that, the library world and scholarly communications has tended to try to invent new technologies, and I think that's sometimes been a mistake. The sort of so-called digital library technologies. We are really blessed with the web, which is a very proven, very simple, very robust mechanism for doing most of these things. So that's part of the context, really, that we have this. The opportunity that we saw at the beginning of the Notify project was that the importance of repositories, or at least the perceived importance of repositories, was increasing. Particularly preprints in repositories, although, you know, in more recent times, I think we're starting to see a growing interest in other types of content. You know, I was talking earlier to software heritage, and so software is becoming a first-order scholarly output, which is encouraging. We're seeing an increasing number of data repositories for sure. I always quote this from Kathleen, but she has this phrase that repositories are having a moment, to sort of say that repositories are suddenly fashionable again, which is great. And at the same time, there are services emerging which can exploit or add value to the content in repositories. And I'm going to talk particularly about peer review and what we call endorsement, and I'll explain that in a moment. So there are a few principles and kind of a strategy behind our approach to developing COAR Notify. The main one really, I think probably the most important, is that we wanted a protocol that didn't connect systems, but that was about connecting the resources, the content in those systems together. So in a sense, it is system agnostic. So long as it can use the web, which any modern information system, generally speaking, should be able to, then we can really focus on the resources. And this is known in software engineering as a resource-oriented approach, and this is important. In programming, if you've done any programming, then you may have come across the phrase pass by reference as opposed to pass by copy. So in a lot of previous digital library technologies, they've really focused on passing copies of information around, particularly metadata. So even things like OAI PMH is essentially pass by copy. What we wanted to do was to pass by reference. So this means that you don't pass, for example, a metadata record. You simply pass a reference to a metadata record and you leave it in its source. We wanted to take advantage of the distributed repositories that I described earlier, which gives us resilience because they're distributed. And we wanted to use a general solution. So what we didn't want to do was to create a protocol where every time we wanted to add a new function to it, the repositories would have to do more development. It's expensive and slow. The idea was to try to find a generalized solution that could be adapted to a number of use cases. So at the heart of the foundation of the protocol is two existing standards. So we didn't invent these. These are already well established. They're both W3C standards. One is called Linked Data Notifications, which is a specification for how you can do what we call asynchronous messaging, so sending messages using HTTP, using the web, between systems, and it has that logical arrangement which you can see there, where you have a sender and a consumer, and the sender sends a message to an inbox, and the consumer consumes messages from that inbox. And the other standard was activity streams 2, which is essentially not quite a vocabulary, but for purposes of this presentation, let's call it a vocabulary. It's a simple set of terms to describe things which you might do with simple notifications on the web. So far, most of possibly all of the implementations of COAR Notify in repositories and services have used this approach, which is to embed the inbox into the system itself. There are other ways of doing this, and in fact, in many ways, the original idea with linked data notifications is that the inbox would be a separate service. But logically, this is okay, and it turns out to be the simplest way of implementing it for so far for the people that we've worked with to implement Notify. if you go to the COAR Notify website, you'll see some other possible architectures documented there, and I think we have the URL at the end, so you'll be able to note that. So this is from the COAR Notify documentation. This is an example of one simple workflow. So this is a dissemination workflow where I have to peer at my screen because it's too small. This is the Create endorsement workflow. So this is, I should give you the background to this. There is a service called Peer Community In. Peer Community In is a service which has a number of communities, communities based around particular academic disciplines, and those communities acting together will review and optionally endorse preprints. And they've been doing this for a while, and we worked with them to use COAR Notify as the way in which repositories could send a notification to PCI and ask for an endorsement, and then receive notifications about reviews and an endorsement if the endorsement was granted. So this is a very simple part of that workflow where PCI is just telling a repository that a preprint, in this case, has been endorsed and has reviews available, and it can send more notifications if there are more reviews. So the idea here is that we're creating what we call bidirectional linking between the preprint in the repository on one hand and the reviews or endorsements in PCI on the other. So they end up being linked to each other. The author can proudly display the endorsement on their webpage in the repository for that preprint and link to the reviews. And PCI obviously links to the preprint. So we developed this for PCI and Society, which is a service run by Eloy, who are one of the major innovators in the PRC world at the moment. So this is a more complex workflow. This is the end-to-end workflow for a repository seeking an endorsement from PCI. So this shows, first of all, the repository requesting the endorsement, and then it shows the different possibilities. So that request could be refused because PCI might consider the preprint to be out of scope of any of its communities, for example, or it can be tentatively accepted, which means that it's in scope, but we now need to find some reviewers. And that process runs through the PCI review process, and then the outcome is either a rejection, so that's PCI saying we are not prepared to endorse this, or an endorsement, in which case they send the notification of the endorsement and they reveal the reviews. The reviews become open and public at that point. So through the COAR Notify project and with the Arcadia funding, we've been able to work with PCI and others to develop this. And this is now working. It's been, the software has been developed in the DSpace repository, so anyone running DSpace 7 or 8 can adopt this workflow and work with PCI. It's very close to being available in ePrints, which is the second most widely used repository worldwide. And we're in the process of developing for Invenio. I think that one will be quite soon, Invenio RDM, which coincidentally means that it will be available in Zenodo, which is a significant general purpose repository service. And we're just beginning the discussions with the Bodleian Library in Oxford to develop a Samvera Hyrax version. So we're gradually introducing this support for this workflow and others into the major repository platforms in the world. So this is just for the people who like to look at machine-readable things on a slide. But this gives an example of the kind of message which is transferred with the notify protocol. So in each notify message, there is what we call the payload. And the payload is encoded in a format called JSON LD. So JSON LD is basically JSON with a couple of minor features which makes it essentially RDF. It's a serialization of RDF. But it usually means that people with ordinary JSON programming skills can deal with it. So it's quite a nice compromise format, and this wasn't our choice. This is the default format for payloads using the W3C linked data notification standards. So we're just following the standards, following the mainstream, and you'll find that there's a sometimes confusingly similarly named standard called Activity Pub, which is the one behind things like Mastodon and the Fediverse, if you've come across that. And that uses the same format and a lot of the same technology. So each payload has properties which are either mandatory or optional, but you'll see there that's a very simple payload. Really, all it's doing is encoding where the message is coming from, where the message is going to, the URL for an endorsement. So this is a resource on, for example, on PCI, the endorsement resource, which is a web resource of some kind, and the URL of the preprint which was endorsed. So it's connecting those two things. And not much else. There's not much else information in there. This is deliberately very simple, very sparse, passed by reference, not passed by copy. But it means that either of those two services can start with those URLs and they can interrogate further, find metadata, or find the PDF in this case, that kind of thing. This is the documentation from the COAR Notify website. So you can see, if you go there, you will see that there are a number of patterns which have been described in this way. So it makes it easy to implement. So alongside the specification of the protocol, we're starting with a fairly lightweight catalog, just documenting the implementations as they arrive. So you can go there and you can find documentation of the workflows like the ones I showed earlier. You can find which services and which platforms have implemented Notify and which workflows they support. You'll see the logos of some of the implementers there. We also have links to some software code bases that people have developed, which you might want to reuse. We have officially developed code bases. We have one available so far, which is in Python. So this is a code base to essentially to get you started with using the protocol. It's a library which encapsulates the protocol. And we have others following soon, PHP very soon, Ruby, JavaScript, and so on. You'll find plenty of information there. So in the pipeline, as I said, we've got ePrints being developed with Aston University and CoSector. That's very close to being ready. In fact, I'm hoping I'll be able to put something on the documentation website towards the end of next week. Zenodo and Invenio RDM, that one's quite exciting because Zenodo is a really important repository, a sort of default repository for many projects. Samvera Hyrax, as I said, PubPub, which is a platform from MIT, PubPub? Yeah, from MIT. They are beginning to develop with us, and they'll be working with the eLife team. So we're starting to see implementation. We heard just in very recent times that Software Heritage, who are over here, they've implemented Notify without us even being involved. They just went to the protocol and they did it themselves, which is really gratifying because it means we must be doing something right to make it reasonably easy to adopt. Either that or their genius is probably the latter, actually. But so the benefits of all of this. Well, as I said earlier, it's systems agnostic, so there's no central point of dependency, and it means there's no possibility of somebody monopolizing this or, just that kind of encapsulation of the commons that we see happen in other domains, other opportunities like this. It's resistance to that kind of capture. It's relatively cheap, and I think this is really important because repositories don't often have a great deal of resource behind them. They're quite often run with a fairly low level of resource in an institution, for example. I've frequently come across repositories where there's no real technical resource available to that institutional repository. There's a repository manager, and they can maybe call on the goodwill of the local IT team occasionally to help them. So by having this arranged around a single, relatively simple technical investment, we're hoping that this will enable a number of use cases to be realized. And it's interoperable. We're using mainstream standards, widely interoperable with the wider web. There's almost nothing in what we've done that is specific to scholarly communications at a technical level. We've invented a very, very small vocabulary. It only has 3 terms in it so far. This is deliberate. We're trying to use the mainstream standards and the mainstream vocabularies as much as we can. And this means that I'm aware of other initiatives using exactly the same technologies already happening. For example, in archiving, there's some related effort going on in the Netherlands, and they will be really interoperable with us. There's the same basic technologies apply. So we're hoping we can start to see a real, people are fond of using the phrase ecosystem, I've noticed, so we're fond of seeing a bigger ecosystem develop around this. And that's all I have to say on this. I think Eloy and I are happy to take questions. Are we going to take questions before the next one? Yeah. Oh, and please note the URLs. The second of those URLs is the technical documentation, which I showed you earlier.
Given that we're a bit tight for time, I think we could take one question now, and then we will do the other presentations, and if we have time at the end, then we can take questions for all 4 of you. So does anyone have a burning question for Paul or Eloy? Yes, Masaharu.
I have a question about the technology point. Is the repository implemented designed to be generic or the service specified? Because if I am a Agile Cloud developer, so if I want to connect to the Notify service,日本語ですいません。もしジャイロクラウドでこの Notify のサービスにつなぎたいとした場合に、その Notify のプロトコルを実装するだけで参加できるようなものなのか、それともやはり個別にプロジェクトにご連絡してやり取りする必要があるようなものなのか、どちらなのでしょうか。例えば気になっているのは認証の仕組みとかどのように実装されているのかとか、ちょっとそういった細かいことが気になっています。
Okay, thank you. So I think there are 2 questions in this. One is about, when you say certification, I think you are referring to security. Yeah. But the other was about if there's any need for a kind of relationship between the services, I think. So perhaps I didn't entirely understand the question, but let me say what I'm going to say and you can tell me if it helps. So in terms of security, we were talking about this at lunchtime actually with Software Heritage, but we have been careful not to prescribe any particular approach to security. So the default situation is that there is no security, it's just open. Obviously, people will not want to run services with an inbox that can receive any requests because as we know from email, spam will become a problem and malicious notifications and so on. But there are a number of well-established web security measures and approaches. So certification is one of them. Just using API keys in the URL is an approach which Zenodo and Invenio is taking with PCI. We've heard of others using simple IP whitelists, which is probably not sustainable for the long term, but all of these are commonly used in web services, and all of them will work perfectly well with this. So what I want to do with the documentation is not to prescribe what people should do, but to document what people are doing and maybe arrive at some recommendations for good practice from that. But I really want to see how they work. So your question really was, is it enough to just implement the protocol? And the answer is not quite. You need to do that, but then you also need to establish the kind of business rules between your service and theirs, you know, what their expectation is, security possibly. We are trying to document that carefully on the website so that by the time you speak to them, it's clear what you need to do, and it's just really the situation of making an agreement. But some of this is the good practice is going to emerge from the experience of the people developing. So we're looking to people like you, Masaharu, to develop some of these solutions, and then we can learn from them and recommend them to other people.
Thank you.
All right, thank you, Paul and Eloy, and let's see if we have time at the end for a more fulsome discussion, but I'd like to introduce our next speakers. Well, what is the elephant in the room? Artificial intelligence. So I think we have two very interesting presentations, or maybe it's one presentation that's going to pursue a little bit further what the impact of artificial intelligence can have on repositories, and potentially how we might be able to really create some interesting services around AI that go beyond just institutional services. Who will be speaking first? I will be speaking. We have Petr Knoth here from COAR, C-O-R-E, the other COAR, the Apple COAR, and Martin Klein, who's from the Pacific Northwest National Laboratory, but also from COAR. Yes. So I turn the floor to you.
Thank you. Thank you so much, Kathleen. We are absolutely delighted with Martin. Can people hear me? Hello? Yeah, okay. We're absolutely delighted to be here today with Martin. And we're doing this sort of double act to raise awareness and to sort of initiate a discussion with the community about how can AI transform the way we work with repositories. We are going to, what we're going to do today is that we're going to give you a little bit of an intro of why we think this is a really important time. Martin will then basically give you some sort of low-level demos demonstrating the capabilities of AI, and it will be easier for you to then imagine how these things can actually get potentially, what kind of things can get incorporated into the way we work with repositories. I will then again take over and give you 4 concrete use cases in which actually we are already integrating something like this into tools that or by building tools that support repositories, and we are going to then wrap it up, and we can have a bit of a discussion about where this leads us. But I'd like to start with why is this AI opportunity really transformational at this time? I think that the really, if we think about the evolution of computer science, then in, let's say, the 1970s, we had technology which created relational databases. And that enabled us to query structured data, basically, in ways that we were unable to do in the past. And what the AI revolution brings is the ability to query in a very similar way as we query structured data sets, also unstructured data sets. And now, because our community heavily relies on vast amounts of unstructured data, effectively research papers are, unstructured data, this should totally revolutionize the way we work. And it's going to, it will happen, whether we like it or not, we need to get ready. This will happen, and it is already happening. And so we want to bring closer the kind of areas in which we think this is going to create and deliver changes. And so the first thing definitely will be the streamlining and increasing of the quality of metadata. We think that it will also bring changes to the way that research papers and information embedded in research papers is actually accessible to our communities. It will be easier to consume science in your own language. It will be easier to understand scientific texts that maybe you don't necessarily have the skills for. So it will be easier to bring science closer to the public. And I personally believe that the entire research workflow will completely change. So we will do, the way researchers work is going to change. We will write papers differently. We will explore literature differently. We will be supported by tools that help us to conduct systematic reviews faster than we were ever able to do, and therefore we will have more systematic reviews. We will be able to review papers faster than we are and proofread them maybe completely automatically. So the innovation and the sort of discovery in the whole ecosystem is going to be streamlined. And repositories need to and have an opportunity to play a very important role in this. And that role will be probably also realized by us realizing that actually the most important thing that your repository will be doing is actually enabling these different services to actually operate on your content. And with that, I'd like to hand over to Martin, who is going to tell you more about what can be done and then start some of the demos.
Excellent. Thank you, Petr. All right. So we thought at the end of the day, nearing the end of the conference, no one wants to look at many more slides. So the idea was to break it up a little bit and show you some demos as well. Those demos are accompanied with some slides to introduce them a little bit better. So I'll go through 3 slides with increasing level of complexity for the demos that hopefully you'll then recognize when it actually comes to demo time. So the first level that we thought about was metadata extraction, right? Something that we're all struggling with. If you ran a repository, I gave you a random PDF file, would you know what to do with this, right? Would your system be able to extract metadata format in order to then ingest it reasonably so into your index? I know that my organization is struggling with this, and so the opportunities for somewhat modern artificial technology here are interesting. We can envision things like, what's the resource type? What is the title of the document that you just submitted to me? Authors, affiliation, persistent identifiers, those are all technical and even somewhat contextual metadata elements that we can potentially address with using artificial intelligence, like technology, let's say. Something that I also know that we're struggling with is this notion of gaining information about embedded resources in a PDF document, for example. So what are your equations in the paper? What are your tables in the paper? Images, what do these images tell you? What are the captions of those images? We've run a lot of experiments and none of them was particularly reliable, so maybe there's a new frontier here of extracting those pieces of information more reliably. I'm sure I'm not telling you anything new when we're talking about textual content summary, and also keyword generation. I'm sure you've all seen use cases like that where, let's say, modern large language models are actually doing a pretty good job providing those pieces of information to you. Stepping it up a little bit in terms of complexity, level of complexity, what we labeled as the bucket of transformation, information transformation by means of applying artificial intelligence sort of technology. I'm sure you also heard of cases where large language models are fairly well equipped to conduct a text translation from language A into language B and beyond. So that is a pretty obvious use case, we think. When we're thinking about metadata schemas and formats and representations, maybe there's an application there for a large language model to help us out, something that we've been struggling with in the past. And maybe to even further step this up, and it also plays into the accessibility topic that Petr alluded to, can we envision different ways of summarizing content? So for example, can you give me an image that represents the content of a paper or of a section of a paper? Can you give me an audio representation of the textual content? So there are advances that are fairly interesting that we can take a look at. I alluded to this already in the previous slide, but the actual description of an equation, right? Is this equation A or equation B? Is this equation similar to the previous one that I've just seen? What does it tell me as a non-subject matter expert, maybe? Something that is dear to my heart is this notion of citation extraction and also the anticipation, basically, or the prediction of the intent of a citation. Something relevant when we're building knowledge graphs, when we're building research assessment sort of tools. What was the intent behind the author including a reference, for example, to a code repository, right? Those are interesting questions to answer, and questions where we can take the citation context, so textual information again, into consideration here. We'll show you that in a second. Something that we labeled more experimental use cases because our confidence level decreases there a little bit, right? But nevertheless, we have a couple of demos that are prepared for you as well. Petr will take over at that point. But can we envision an environment where we can explore our textual content by means of natural language, right? So really envision an environment where I'm asking a question to a very domain-specific document and I get a response that even I, as non-expert, can digest. We ran a number of experiments in my environment with the Plutonium Handbook, which is a physical printed book that's out of print, and we're able to help educate and train nuclear engineers to actually start answering questions that they had. Similar use cases would be, for example, the consumption of manuals for instruments. Right? Often you buy a very expensive microscope and it comes with a 1,000-page manual. Well, no one is going to read this, and certainly your postdoc is not going to read this. However, if something goes wrong, maybe you want a question-answer system based on natural language and the corresponding responses there. So those are interesting use cases, I think. The same holds true for data. Right? If I gave you a random data set, would you be able to analyze what this thing is about, what this data set is about? Well, maybe would be my answer. So some interesting developments there recently. If you're familiar with Databricks, for example, a company in the US that provides a tool called Genie, which translates your natural language query into SQL in order then to query the data set and give you a natural language response back. Quite an interesting concept in terms of exploring, zero shot, if you will, exploring a data set and see what sort of information you can derive from a data set that otherwise comes with no metadata. And I'm sure the same thing holds true with code. Maybe Microsoft Copilot is a good approach to this, right? Can we interrogate by means of natural language certain code snippets that we're interested in? Something that I know Petr and I are personally interested in is this notion of if we had a large corpus and we were able to connect the dots basically between textual documents, right? Can we interrogate the corpus by saying, paper A obviously used methodology 1, 2, 3, and 4. What other papers in the corpus do you know about that also use methodology 1, 2, 3, and 4? And connecting those. I think the value comes in when these papers are from very different domains, however use the same methodology, then we have real net knowledge gained, right? And of course the same holds true with other parameters such as data sets, right? Which related papers, ideally from different domains, use the same data set or derivatives thereof. So interesting sort of dimensions to think about there. Trend analysis is something that we've talked about frequently. The notion of, well, is there terminology that we can predict? Are there research directions that we can predict? Are there cross-domain collaborations that we can predict? Also goes towards plagiarism detection and so on and so forth. I'm not going into details there because we also don't have a demo for that. So I think with that, I'll stop with the slides and start with a little bit of a demo. With a caveat, of course, that this is just a very simple approach. No guarantee for correctness, no guarantee for perfection, just a few pointers to hopefully spark your imagination a little bit. I used Google's Gemini. 2 different versions, doesn't matter. Very simple chat interface, and it allows me to upload documents into the interface and interrogate the document, right? So just to give you an idea of what is potentially possible here, I asked it whether it was able to parse the text of a PDF document. It said, yeah, sure, absolutely, let's go. Oh, actually I need to back up a little bit because I need to show you the PDF document. So I used this document at first, something that was on my to-read list. It's titled, right, Measuring the Value of Research Data, has 3 authors, a contributor, some metadata, table of content. I'm just going through this very quickly. Executive summary on page 3. Looks like a typical paper, right? A table with a caption, figure, with a caption, another figure, and so on and so forth. And at the bottom of the document, as typically found, a whole bunch of references. As you can see, not necessarily particularly well structured, but a whole bunch of references, right? So, using this document, uploading this document. Oh, come on, where you go? I asked the Gemini whether it could please provide me with the title of the document. And as you can see, it did okay, measuring the value of research data. I said, great, thank you. Lesson learned for prompt engineering, in case you didn't know this, being polite actually helps. So I'd always try to be polite and say thank you, please, things of that nature. Do you know who the first author is? Well, yeah, Florian from the University of Mannheim. Well, that's great. And since I looked at the title page of the paper, I knew that the author's contact information was left there as well. So kind of sneakily, I asked it whether Florian had a phone and whether Gemini knew of the phone number. And indeed, it was able to extract the phone number. You may have noticed that the ORCID of the author was not left in the paper. So I asked Gemini to use whatever resources it may have to find the ORCID of the author, and indeed it did. Right, by looking in the Google search engine, of course. I asked what language it was written in, something that we've had issues with in the past as well, to reliably classify that. English. Then I asked it to translate, please, for me, the executive summary section. Right, so I didn't tell them, the entire document, but just a particular section. So it needed to find out which section I was talking about, and then translate it. In this case, it translated into German, because I was able to assess the quality there. It seemed fine, but of course also translated into Japanese. Leave that up to you to judge whether that's good or not, but it was able to take the executive summary section that I asked it to. I was looking for, trustworthiness of the document, and said, yeah, it's probably pretty trustworthy because it comes from the German research data infrastructure, and it seems to be published in a reputable venue, so that seemed to be fine. Then I asked it to extract the caption of table 1 for me. So again, it needed to go into the document, identify what table 1 is, know what a caption is, and return it back to me, and indeed it did fairly successfully. Going towards the notion of accessibility again, I asked it to describe to me the content of figure 1. How would you textually describe figure 1? And without going back to the document here for the sake of time, it actually did a pretty good job outlining what the figure is about. I asked it for detail on the legend, I'll skip that. How many references are in this paper? Something that we've also been somewhat struggling with to find out. This number is actually not quite correct, so again, there's no guarantee here for perfection. But my point is, I asked it whether it could take the references and encode them in BibTeX for me. So I could use that file potentially right in my repository or even in my Overleaf or other sort of composing environment. And it did a pretty good job returning me BibTeX. Right? So there also is this notion of formatting of information for downstream processes that is pretty interesting and potentially very reliable. Just scrolling through this here quickly. All right. Then I ask it, hey, do you know about FAIR? Which metadata schema should I use to create a metadata record that follows the FAIR principles? And it gave me a whole bunch of options, Dublin Core, DataCite, talks about schema.org, and so on and so forth. And I said, okay, well, this is really good. Could you create one of those records for me? And it did. It used a DataCite metadata schema. And did a pretty decent job on this, just eyeballing it, and actually gave me a couple of keywords already, right? Data valuation, research data, FAIR principles, seems decent. And then I said, well, I really don't like XML, can you give me JSON? And indeed, it did that too. All right, so I asked it whether there were other resources that I should reference when I talk about this paper. Did a decent job in this context too. And I think I'll stop here with that. Okay, so we talked a little bit about the notion of audio summaries, right? So something I want to show you, this is Google Notebook LM, and they have an opportunity to create basically a blog and a podcast about your document that you upload. And it, in fact, gave me
We're swimming in it, aren't we? Data, every click, every transaction, every sensor reading.
Yeah.
It's just constantly being generated.
It really is. And everyone's talking about this data-driven economy.
Exactly. But, beyond the buzzwords, how do we actually figure out what all this data is worth?
That's the million-dollar question, quite literally for many businesses. It's not enough to just collect data. You need to understand its value to make smart decisions.
Yeah.
All right, enough of this, right? But you get the idea. So automatically generated, cool people talking in a dialogue fashion and help you potentially explore the content much more so, right? Yeah. Can we table your question?
It's just that you can also ask them questions.
Right, yeah, all right. Right. So I wanted to show you a couple more things. So I used actually a different paper that I wrote a while ago because I knew the paper and I knew how it was structured. Nothing too crazy here, only to point out that there are a whole bunch of footnotes with URLs in that paper that I wanted to see whether models like that can help us extract those and make sense of those. So, well, first of all, I thought back to Isabel's presentation and I asked it whether it could let me know what the resource type of this paper is, and please use the COAR, the latest version of the COAR resource vocabulary. And it said, okay, I can do that. It's version 3.2 and it's a preprint. So I guess, yay, right? Yeah. extracting links from PDF documents, something that we've been struggling with. If you've ever endeavored that, it's a humongous pain. And here it actually works all right. So it can extract all links that it found, which is good, but obviously not good enough. I also asked it whether it could classify those URLs for me into one of three classes: software, dataset, and others. And it did a pretty good job there too. A whole bunch of software links that I know are correct, one link to a dataset, and a couple of others. You're not surprised that an ORCID link is classified as others, right? Okay, this is great. So could you now please tell me where in the document did you find those URLs? Something that very few other tools are able to help you with. And here it did a perfect job in saying, okay, I found those URLs embedded in the text, and you can argue whether the header is text or not. I found those URLs in the footnotes. That's perfect too. And I found those URLs in the reference section. So again, something when we're building graphs and connecting the dots, basically something rather relevant to explore. All right, so then I told him, oh, well, I would like to distinguish citation intent. So for those software links, can you tell me whether the author intended to cite this piece of software either because they created it, or they used it, or they just mentioned it? And they also, because I wrote the paper, I know, did a perfect job saying I used all these software packages. I mentioned this one software package, and there was nothing that I created because I didn't code anything for this paper. Last but not least, this thing where, you know, you can, oh, I can't do this visual summary. Never mind. The last thing I wanted to show you was methods. I asked it what methodologies were used in the paper, and it said, you know, Levenstein distance, semantic similarity checks, and so on and so forth. And then I asked it, well, do you know of other papers, ideally from different domains, that use the same methodology? And if so, could you please link to them? And it did, right? This is my own paper, and then here, there's a paper from economics that used the same methodology, or parts of it, humanities, computer science, and biology. So there again, we can do this sort of cross-domain linking based on the common denominator of methodologies. All right, one of my favorites. Hey, Gemini, if you had 10 seconds to convince a funder to financially support your work based on this paper, how would you advertise your work to the funder in 10 seconds? And it gave me actually a pretty decent response, right? And again, this is just me toying with the tool, right? But you get the point of the more information you provide, the more of a persona basically you create with this, the better potentially the output can be. One last thing, real quick. Dataset exploration. I found a random, and this is literally random, me just browsing through Zenodo, data set. It's on something COVID related. I have no idea what it is. But it is a CSV file. And you see the column headings, right? There's something that I don't even know what it is, some iris number, some panel, long COVID, timing month, and so on and so forth. I literally just copied this the snippet of the CSV file into Gemini right here, right? You see that all the formatting is gone. No instructions beyond that, and it gave me its basically interpretation of what it just saw, right? So this appears to be a data set containing results from a biological assay. Assay means this, NPX means normalized protein expression, apparently, and a further description of what these columns may mean, right? So I guess the chances are pretty good that for open content, some of these models have seen some of the data and can interpret them reasonably so. And this is just literally the tip of the iceberg on how to explore data sets that you otherwise would have zero information about. Right, so I think for that, I'll hand it over to Petr, who will expand a little bit on the demo horizon.
So as we are exchanging laptops, I'd like to ask you to, I wonder if you could raise your hand if you know a librarian who complains that they don't necessarily have good metadata but also complain they don't have time to create it. Oh, so few? So few people know a librarian who is not satisfied with metadata? That surprises me, that seriously. Or maybe you're just tired and I don't believe you in this case. Okay, so what I'm going to do is I will attempt to give you these 4 demos on things that we've been working on with connecting repositories COAR. And the first one will be on question answering, and then the 3 others will be on basically some of these extraction things, similar tasks that Martin described. But the difference between my presentation and his is basically that I will show you actually concrete tools in terms of how this can be embedded into workflows that support repositories, basically. So with the first one, let me go to COAR GPT. COAR GPT is actually something which we created 2 years ago when LLMs were still like not everyone, like everyone already knew about them, but we didn't have enough time to play with them. Most of us. And we, at that time, did research which actually got the Best Paper Award at TPDL, which was looking into how good are large language models with referencing sources from scientific literature. And at that time, they were complete crap, because the vast majority of the references it would give you, and it gave you real references to fictionless papers. So 80% of those papers were fictionless. And so we said, okay, we need to do something about this. So we built a tool that actually does question answering on top of the core data set. So effectively feeding the core data, the core content, using a method which at that time no one knew, but now everyone have probably heard by now of retrieval augmented generation. So effectively the way it works is that you generate a search query where we ask basically ChatGPT to translate basically the query from the user to Elasticsearch. We retrieve content from COAR, and we then pass that content, pass those works back to ChatGPT, and we ask ChatGPT to synthesize a response specifically from those papers. So the way it can work is that you ask a question as is indicated in this paper. For instance, here is, what is the effect of changing the composition of metal alloys on their mechanical properties? And then it would come up with the answer together with the references, grounded in scientific evidence. And you can see that this somehow forces the models in actually, the highlighted phrase effectively shows here some content which is actually in one of those references. So it directly really uses it. It becomes much more trustworthy. And so we asked actually users, we wanted to know if it increases trustworthiness, and indeed we did a study which shows that yes, it increases. We looked at 3 things: comprehensiveness, trustworthiness, and utility of the reply, and we found that it worked for all of them. What I want to do now is basically that I want to mention another thing, which is a huge opportunity. 68% of content in COAR is in English. The rest of the content is in all sorts of other languages. At that time, we only tested it with English, but what I have done is that I have actually prepared this phrase in Japanese, apologies, and to the system which we created. I'm really struggling here with navigating somehow my screen. I'm really sorry for that. And searching for my browser as well. Okay, good. And I will submit it there. It will probably take a little bit of time. But I also already have the reply here actually, because I cheated. And again, you can tell me if this is good. The question was basically about, actually I forgot, but I have the answer in English as well. So this is what are some of the biggest challenges and opportunities for the use of AI to support open science, okay? And so I don't know if, how many Japanese colleagues think that it's an absolutely terrible answer? What they see? It's small on the screen. It's small on the screen, okay. So this is the answer that it generated, and you can see that below the answer I have references which are actually to English articles. So I'm querying in Japanese, obtaining resources from COAR in English, and then based on those resources, I'm synthesizing a reply in Japanese. But what is actually even more powerful, and COAR GPT can't do it at the moment, is that in principle, it should be possible to take into account all content, regardless of the language, and translate the reply into any language, basically. So in principle, I should be able to query in Czech, because that's my native language. I should be able to take into account papers in any language that exists and synthesize the reply to Japanese, for instance. And so I think this is incredibly powerful, and it is a huge opportunity, I think, for us to bring science closer to people. Really like allow them to do things and understand things that they would not understand, and actually for all of us to have a more comprehensive understanding of the research that has been done. Because at this point in time, I'm ignoring Japanese research written in Japanese because I just don't have the way of accessing it. So that's my first demo. And I'm going to go to the next one. If I manage to change, yes, and I think I will succeed. Then the next thing which I wanted to show you is on something called United Nations Sustainable Development Goals. So I have heard from many institutions actually that they wanted to know how their institution contributes to United Nations Sustainable Development Goals. Some institutions need to actually report on that to their governments or to their funders. Are you doing something to support climate action, for instance? These are the kind of questions that they are asking. And the way to answer these questions is that you would normally need to go through, you would need to ask your researchers basically, or so you can go to your repository and you can tag all papers in your repository with respect to the United Nations Sustainable Development Goals. It's a lot of work to do something like that. So can we automate this process, and can we develop something that helps people to do it? Now, one thing which you might say after seeing what Martin said is that, okay, we can do something really simple. We can submit all papers to a large language model and we can ask it what is the SDG. Doesn't work. It doesn't work for multiple reasons, but the key reason which I would like to highlight is that in COAR we have about 300 million metadata records. If I was to submit 300 million calls to ChatGPT, then I'm completely bankrupt, basically. I have no way of doing it, basically. So, and it's also incredibly slow, because we can't basically get this sort of throughput. So I can't do this. So how can we do this? So for those of you who are a little bit technical, there are three types, effectively, of models: encoders, decoders, and encoders, decoders. The large language models that you probably use most of the time are decoders. Okay, they take a lot of power, basically. Even, in fact, they take quite a lot of power even during execution. Some of the encoder models, which are very good for classification, are incredibly fast to execute and very cheap. And so what can be done here is that we actually created a new model, which is not a large language model. It's a model which comes from the BERT family of models for multi-label classification of publications into sustainable development goals. We actually didn't do it completely in a zero-shot setup, which means that we actually fine-tuned the model with 500 examples, which we manually tagged. And what we obtained was basically a performance which was higher than what we would get with zero-shot large language models. So we had to manually annotate, yes, but it was only 500 examples. And with 500 examples, we obtained a model which can run orders of magnitude faster than large language models. So I think that's the really nice trick about this. And I want to show you what the result is for, if I can find my mouse, which I'm struggling with. I am there, okay. That's interesting, because you can't see what I can see. Okay, how do I do this? Sorry, okay, apologies. Okay, now I think it's better. Yes, so what I'm showing you now is something called the COAR Repository Dashboard. So any institution that runs a repository that is indexed by COAR can ask to get an account in the COAR Repository Dashboard. And within the COAR Repository Dashboard, we have a module which is called SDG Insights. And so I'm doing it for the Open University, which is an institution I'm familiar with. And I can use this module basically to see how basically papers from my institution are tagged. So for instance, I can see that my institution is very strong on quality education, and I think let's say climate action is only the fourth most common resource, basically. So we effectively run the model across all the content in the repository using this lightweight model, which was not particularly expensive, and we now also can provide, like, you can look at all of those papers. You can see that some of the papers are tucked into multiple categories, and you can see that for each of the papers I also have confidence scores. So I can see I have, like this paper, for instance, is responsible consumption and production, 76.81 confidence score. And what I can then do is I can then click and I can open it directly in the repository. This is done by, unfortunately, internet is a little bit slow here, I think, but this is done via an OAI resolver. I have done another paper here. This is how it would look like. So that's SDGs. A very similar module we have now for data availability statements. So I know a lot of institutions that would like to extract data availability statements, effectively information about where is the data, where's the research data stored. And we have a module which is very lightweight. It's not based on a large language model. And it basically enables the repository manager to see and review phrases that we extracted for data availability statements. So we effectively processed, again, the papers from a repository, and I can click on review data availability statements, and I can get exactly the phrase, and I can then decide whether whether this is good, correct, or wrong. The idea is that the repository manager can effectively go through this in a human-in-the-loop process. So effectively, I have here a situation in which I'm not doing it completely automatically, but I have a human reviewer. And then if the human reviewer says correct, then potentially this content can go and create a new field in the metadata, basically. So it's a way through which I can significantly limit the effort that would be needed by the librarian to review these data availability statements. Okay. And that's great. And with the last demo is actually not a demo. It's so I will return back to my slides. And it's just something that I want to mention. This is work that I'm doing together with the people from Software Heritage who are here as well. And basically this is about extracting software mentions from research papers. So what you can see on the screen is a manuscript, and within that manuscript there's a phrase basically which says that the Advion Chipsoft X software was used to capture an optical image of the prepared slide on a flatbed scanner prior to analysis. And so what we would really like to have as librarians, or what my librarians would like to have for sure, is a structured representation of this stuff. So they would like to know that Advion is the publisher or the creator, basically, or the company that produced that software, and that the Chipsoft X is actually some piece of software. And what we have done as part of the project is that we have actually used zero-shot large language models for to test, and you can see actually, we tested with Llama, with other models basically, and we received certain performance metrics basically, so we know how well it works. The really exciting thing for me was that there is a piece of software which was created before our project, which is called SoftSide. And that is a tool that was trained basically on manually curated data. It's also a fairly small collection, of course. If there is more data, it's always better. But with the zero-shot LLMs, it happened earlier. It's not the most recent models. And what we received with the zero-shot LLMs is a significantly higher performance, and really very significantly, than what we get with the trained software. So it's a slightly reverse situation than the one which I showed you on the United Nations SDGs. And I think in this case it kind of the problem is I would absolutely love to, but we can't run it across all of the research papers that we have at the moment. It is a research problem for us. So we will probably, as a community, we will come up sometimes with extraction tasks where the LLMs have a very good performance, but actually we have a problem with scalability. You know, we can do something with LLMs. We would love to have it. People might think, oh, why are you? You must be incompetent or something. I can extract this. I can extract. Why don't you have it in the metadata? And you know, when you need to launch and run things scalably across millions and millions of resources, it's not so simple. And so testing will be required. Will be performance evaluations will be needed, and you know, it might be that it's task dependent. Certain tasks will require certain different setups. So that's all from me in terms of the demos, and I'm going to come back to the presentation, where we have with Martin the last two slides, and I will get them from here, and I'll do slideshow. Yeah.
Okay, great. Thank you, Petr. So, of course, you know, this again is just a few pointers to designed, or we're hoping that this sparks a little bit of your imagination. But of course, this is not a solved problem. There are lots of issues, and we also don't claim completeness on this slide. But there's a couple of thoughts that came to our mind when we're talking about, okay, how do we actually use this, right? What's the step forward? What are the issues still? And probably the main one is how to put this in production, if at all possible, right? Do we have the resources that it takes to scale this up, both in terms of compute resources, but also in terms of human resources, right? Do you have the qualified senior data scientists on staff that would be able to reasonably so utilize this technology? The answer I know in my environment is, well, maybe two. So those skill sets are hard to come by and very expensive, right? In terms of integrating these sort of technologies and principles into your workflow, is this something that you just turn on and then leave and trust that it does the right thing? Do you have a human in the loop? How does quality assurance work? Those are all pretty open questions, I think. The return on investment, right? Always a question to ask about this. And neither of us are lawyers, but also, of course, the legal question is an issue. We've alluded to this throughout the conference. Right, there's this notion of fair use, which is currently basically being severely questioned, at least in the US. So we'll see how that goes in terms of copyright and other legal questions there. I also want to mention the notion of cybersecurity concerns. At least in my environment, we have a whole bunch of somewhat modern large language models that we can use, but they're all in a box, right? They can't talk to the outside world. They cannot connect to the internet, just for cybersecurity reasons. I can't use DeepSeek, right? Because don't even get me started. So there are concerns in that context as well, that we have more questions about than answers at all. So I think with that we'll do a tag team, and Petr will lead us to.
So. We wanted to end up a little bit on a positive note, and on a note which we have here some questions which we are not going to answer. But maybe as you walk outside of this conference, you can keep thinking about them. So we are asking ourselves, like, what if we had access to a global corpus of all open access research works, of everything basically, and we were able to scalably run any kind of AI process over them? We are not in that situation at the moment because, first of all, we probably don't have this corpora completely on one drive in a fully comprehensive fashion. And secondly, we don't have the resources to at the moment do it, but we might in the future. And so once we have it, what would this enable? What would we do? How would we utilize this, and how would we govern such services? And it would probably, in my opinion, it wouldn't be one service. There would be many, many different services. And so the key question is really what needs to happen so that we can apply AI responsibly, equitably, scalably across this whole corpus of open access research. And with that, I'd like to finish. Thank you very much. And me and Martin are here to answer any questions that you might have.
So we're coming to the end. I mean, we might have time for one or two questions. So I noticed that Jen has her hand up here, and Paolo has his hand up.
Thank you, because I, like you, think this is very exciting, since I am also one-person repository operator and have been uploading batches using Copilot and pulling out things that take a long time. But I also think, like, as a person who thinks about equitable access to things, I'm also thinking a lot because, Martin, you mentioned something that is interesting. I'm a person from Canada who grew up in Canada who says please and thank you to AI all the time. And then I read an article about the extra costs, like it costs millions. I think Sam Altman said some comments about the extra millions in operations it costs to say please and thank you. And so I'm also have been reading a lot of information about environmental inequity around AI and some of the impacts we've seen around Google operation centers that have come up. And so I'm just wondering what Petr just said about if we had the whole world open to us as we do all of these things, what can we give back in terms of do we set up more water where we're leaving this imprint? Or what is the practical thing we can give back to replace what we're taking out? I don't know. Just thoughts off the top of my head.
Maybe just a quick one. Neither do I, but I would expect, I expect research and innovation and discovery to rapidly accelerate, basically. And I think that's what we can give up. Give back, sorry, not give up.
Thank you. Very interesting. We are going through the very same problems of scalability, performance, and we are trying to use these small large language models that still are very good. For example, for spam detection, we are using them, but impossible to use on a large scale. So if we have to find ways to optimize the number of records we are processing, because otherwise it's just impossible. It will take forever, even on your machine, right? No, I was curious really about this very simple but yet very effective idea that you had, of using ChatGPT between your search and your index. And I had two questions. So the first one is how modular it is. So if we can, for example, as OpenAI, try to use it and test it in different ways. And the second question that came to my mind is, since we have in our collection also data, software, and so on, maybe we could try to answer even more complex questions, which are kind of bringing together publication, data, and software. So of course, this is a technical discussion that is related to how you rephrase your queries into something that is meaningful for our indexes, which is probably the interesting and juicy part. But is it modular enough, you think, that we could start from your code to run an experiment, maybe write a paper together or whatever, or do you think it would be too much work?
Maybe, so if I'm only responding to the core GPT part, basically, then that is actually about 100 lines of code. So it's an incredibly, lightweight piece of code, basically. It could be, and we've done, because this was a scientific experiment. We took certain, expectations. For instance, we decided that the response should be 150 words, and we decided that it should do a retrieval augmented generation on 5 documents, basically, because we just wanted to have certain experimental conditions. But of course, one could do many more experiments. You could expand on this. So it would be very easy to tell someone exactly how to rewrite this, and they could test it. If OpenAI wanted to do this, I think it would take a developer an afternoon to build something like that on the OpenAI corpus.
We done? Yeah, okay. So maybe a thought on the second part of this question. I couldn't agree more with you that there is great potential in pockets, right? Using small-ish language models, right? When we're thinking about even edge computing, right? No one can run Gemini on an autonomous vehicle sort of thing, right? The other part, I think, also is the multimodal approach of creating connections between related or seemingly unrelated artifacts, your code, your data, your manuscript, your video, your workflow, all these things, right? And that is something that humans are horrible at. However, those machines are showing promise, let's put it this way, right? And I hear this from my climate researchers that is the way forward to actually make a leap, right? The next frontier, the next step towards solving big problems, because we've kind of cognitively reached the limit of humans, because we can't make these connections.
Any other questions? I think we're going to have to wrap it up fairly soon, so I'm not seeing any other hands. Was there a
For either of the two of them.
I think we probably don't have time for that, I'm afraid. So, well, Petr, Martin, thank you so much for giving. For giving us a glimpse into the future. It's very exciting, but also kind of intimidating and scary. And it kind of brought us full circle, because the first session we had of this conference was about the impact of AI bots on repositories and how it was causing very large service disruptions. And then, of course, our last talk is about what we can do if we can, harness the value of AI. So I have a couple of closing comments before we let you all go, and I'm hoping that everybody will stop doing their email, will close their computers. I'm looking at Paulo, just waiting for him to close his computer, and pay attention to the last few minutes of the presentation. Sorry to call you out on that.